Okay, so we're looking at our last target for the unit, which is target 6. We're looking at inverse functions. Now, you've heard of inverses before, like when we're solving equations. If you're going to solve an equation, you're always going to do the opposite or do the inverse operation. So if you're adding 3 to something and you want to solve it, you would subtract 3 from both sides. Those are inverse operations. Now we're going to look at inverse functions. So there's some more notation here. This unit is very heavy on notation. To denote inverse, we're going to use this. It looks like f to the negative first power. So that's read as f inverse. Okay. So first, if we're going to write the equation for an inverse, we're going to follow these 4 steps. So I'm going to replace f of x with y. So this equation will become this. Now I'm going to switch the x and the y values. And I'm going to solve for y. That means I want to get y by itself. So to do that, I'm going to subtract 1. And then to get rid of the 1/2, I'm going to multiply both sides by 2. So this will become, okay. So I solved that for y. Now instead of writing y, I'm just going to rewrite that as f inverse of x. Okay, so this is the inverse function. So notice that in our original function, I'm taking half of x and I'm adding 1. In my inverse function, I'm doubling x and I'm subtracting 2. All right, so now we're going to graph both of these on the same grid. So I'm going to graph this function in green. It's in slope-intercept form, where m is the slope. That's rise over run. So how do you go up and over? And then b is the y-intercept. Okay, so my y-intercept is 1. And then my slope is 1/2, so moving up 1, right 2. So this is the original function f of x. My inverse function, I'm going to graph in red, so that's also in slope-intercept form. So my y-intercept's at -2. My slope is 2, which is the same as 2 over 1. So I'm going up 2, right 1. So that one is f inverse of x. All right. So now we're going to use interval notation to name the domain and range for each of those functions. So I'll start with the domain of my original function. So that's the green line. The domain, it goes left forever, so -infinity, and it goes right forever. That's +infinity. The range of f, it goes down forever, it's -infinity, and up forever. That's +infinity. All right, so now for the inverse function, or the red one, the domain, it goes left forever, right forever. The range, it goes down forever and up forever. All right. So the second one. Now I've got a quadratic equation, and I'm going to find its inverse. So we're going to walk through these same 4 steps again. So first I'm going to replace f of x with y. Then I'm going to switch x and y. And now I'm trying to get y by itself. So I've got y equals the square root of x plus 1, which means f inverse is the square root of x plus 1. Okay. So now I'm going to graph both of these functions. Now notice here our original function has a restriction on the domain. I only want x values greater than or equal to 0. So hopefully remember, hey, this is quadratic, so I'm going to get a parabola. The -1 is a vertical shift, so it's moving everything down 1. So my parabola will start at 0, -1, and open up from there. If I make a table just using these x values for my restriction, that could also help me graph this. So I'm just substituting these x values in for that function. I'm going to graph them so I get something like this. Okay. So now I'm going to graph the inverse function, which is that square root function. Again, hopefully we can graph that just based on what we learned for our transformations. The square root function usually starts at 0, 0, and then it's kind of a swoop like this. But that minus 1 under this, I'm sorry, the plus 1 under the square root symbol moves me left 1. So I'll be starting here and then doing the swoop up. Again, if you want to make the table, let's see here. If I use an x value, I can use an x value of negative 1. You know what? I'm going to make that a negative 2. Let's see what happens. So if I put in an x value of negative 2, and I do negative 2 plus 1, I'm doing the square root of negative 1. If you try putting that into your calculator, or maybe you remember, you cannot square root a negative. So there is no value for that. Now if I put in an x value of negative 1, negative 1 plus 1 is 0, and the square root of 0 is 0. If I put in negative 2, negative 2 plus, not negative 2. I put in 0, 0 plus 1 is 1, and the square root of 1 is 1. And I could keep going to kind of create this graph. So negative 1, 0 is here, 0, 1 is here, so I'm going to get something kind of like that. Okay. Again, you don't need to make those tables if you remember your parent functions and the transformations that we learned back at the beginning of the unit. All right, so now I'm going to use interval notation to write the domain and range of these two functions. So this is f inverse in red, and this was my original function in green. So the domain, why don't you go ahead and write these out and then check back with me. So pause this if you need to. All right, let's check it. Sorry, that was really loud. All right, domain of f. So that's all the x values. Okay, so I start in an x value here of 0. I'll have brackets there. And then that f of x function, the green one, goes all the way to the right. So that will be infinity. The range of f, so now I'm looking at my y values. My smallest y value here is at negative 1 with brackets. And then it goes all the way up forever. That's positive infinity. When I go to look at the inverse function, the domain, so my x values, I start here at an x value of negative 1. I'll have brackets. And it goes all the way to the right. That's infinity. And then my range, that's the y values. So my smallest y value is at 0. And it goes up forever, so that's positive infinity. Now, if you look at the domain and range, you can see it a lot better in this problem. The domain of the first function became the range of the inverse function. And same here. The range of the original function became the domain of the inverse function. So the same thing was happening back up here in this previous example. Okay, it's just a little bit harder to see because the domain and the range were the same for both functions. So again, inverse functions just means the opposite. Long story short, you're switching the x's and the y's. So we can kind of see that happening in the domain and range. And we will do some more practice with this over the next few days.